Let's begin by understanding what is STP and why do we need it. STP stands for Spanning Tree Protocol, which is different from Shielded Twisted Pair, which is also called STP. This protocol is designed to prevent loops associated with redundant layer 2 path and its implications by allowing only one path to exist between the source and destination and block all other paths. In network layer, we have routing protocols to prevent loops and configure the optimized path to travel from source to destination. Although STP fulfills the loop prevention part, it does not tell the device how to send the frame, only where it should not send the frame. STP protocol logic utilizes spanning tree algorithm or STA to calculate instances of spanning tree. In other words, STA is the brain of STP that tells the protocol which port or bridge role this device should take. STP works in the same way for both bridges and switches. Routers and end hosts do not run STP, even though they perform data link layer encapsulation and decapsulation themselves. Loops are the most devastating objects in a network. We're always looking for ways to prevent or eliminate them at layer 2 or layer 3. Loops exist whenever there are multiple paths between two ends. So why doesn't other layers have loops? The answer is simple, because there's only one path. At the upper layers and transport layer, the processing doesn't consider about how the destination is affected because there is only one destination. However, the port addressing at transport layer and session establishment at session layer is configured based on the assumption that the network and data layer will be responsible for transmitting the data correctly. On the other hand, physical layer doesn't have loops because the cables itself only have two ends. You may ask now, what about Ethernet? Doesn't it allow multiple hosts on the same subnet? Yes, you can have multiple hosts on the same subnet, but they all go through the switch in the middle. The switch makes itself transparent, so user didn't feel like it was an obstruction. The switch makes itself transparent, so the devices doesn't feel it's like an obstruction. At the network layer, loops are dealt with a little differently. In the previous lessons regarding routing protocols, we mentioned protocol logic that prevent loops. These protocols have a different approach. They try to eliminate loops by not using that particular path. But when STP is in place, it eliminates that path instead of simply telling the device not to use it and shut the entire looping portion down. Now let's take a look at how a loop would form and what are its side effects. Like previously mentioned, loop itself is created by redundant links. How? When you have multiple paths toward a destination, yet with no mechanism electing the best path, so data has no idea where it should travel in order to reach the destination.